Okay, number 1, 2 cards will be selected without replacement from a standard deck of 52 cards. Find the probability of the following events and enter your answers back to us. Okay, so our 2 cards being drawn, these are our 2 events. And then without replacement, this tells us that we're looking at dependent. Because after 1 card is drawn, it changes what's in the deck. Okay, so let's look at A, where we want to know what's the probability of drawing 2 queens. So we're going to find the probability of the first queen that we draw, and then we're going to multiply by the probability of the second queen that we draw. And we actually did a problem like this in the last section. So probability of the first queen, well, there's 52 cards in a deck. Are there? 4. Alright, so we have our cards, we took a queen. How many cards are in the deck now? 51. How many queens are in the deck now? 3, because there's 1 in our hand. So the probability of the second queen changes. Okay, it's dependent on the first draw. And now we just times these together. So 4 over 52 times 3 over 51. Wow, think about playing cards. There's a 1 in 221 chance of drawing 2 queens at a time. Okay, let's do B. So now we're looking at both cards are face cards. So we're going to take the probability of drawing a face card times the probability of drawing a second face card. Okay, so how many cards are in the deck? 52. And how many face cards are there? 4 jacks, 4 queens, 4 queens. There's 12. Okay, so I draw my card. I have 1 face card in my hand. How many cards are left in the deck? 51. There's 1 in my hand. How many face cards are left? 11, because there's 1 in my hand. I want to draw 2 face cards. So see how this second probability is changing based on the first. Our totals are changing. That's dependent. Okay, now we multiply. So 12 over 52 times 11 over 51. Reduce. So this one's a little better odds. There's now an 11 out of 221 chance that you can draw 2 face cards. Okay, let's do our last one. C. We want the probability of a 5 and the probability of a jack. Okay, so we're starting with our 52. How many 5s are there? What's the probability of a 5? There's 4 5 cards. We drew 1. Okay, how many cards are left in the deck? 51. Well, how many jacks are there? So this time there's still 4 because these are 2 totally different cards. They're unrelated. Okay, so let's multiply. 4 out of 52 times 4 out of 51 because we're dependent. So 4 out of 663 that you would draw a 5 and then a jack.